I once watched a file server migration turn into a Monday morning ticket storm because every copied share looked fine in the GUI. The share permissions said the department group had change. The users still got access denied. 2 admins clicked through folders for hours before we found the real problem. A non-inherited deny entry 3 levels down, copied from an old project folder nobody owned anymore. The share layer was open enough. The NTFS layer was not. If you only check one layer, you are guessing. The manual permissions workflow breaks as soon as you have more than a few shares. Explorer shows a snapshot, not a fleet report. It hides inherited entries until you go looking, and it encourages one-off fixes that nobody can reproduce. The naive script is worse. Create a new access control list, slap a few rules on it, and call Set-Acl. That can destroy owner, audit, inheritance, and existing access control entries. An access control list, or ACL, is not a flat text file. It is a security descriptor with history, inheritance, and ordering rules. Treat it like production data. The pattern is simple, and I want it burned into your muscle memory. Get the existing ACL object, modify that object, set the same object back. Never build a production file system ACL from scratch, unless you are provisioning a brand new, empty test path with a known template. Also remember the 2-layer rule. Effective access is the most restrictive result of share permissions and NTFS permissions. Full control on the share does not beat read on NTFS. Change on NTFS does not beat read on the share. Most access denied tickets are one layer contradicting the other. Start with the path, preferably using -LiteralPath so brackets and other special characters do not surprise you. Use $ACL equals getACL.literalPath$path. Create a rule with system.security.accesscontrol.filesystemAccess rule, using an identity, rights, InheritanceFlags, PropagationFlags, and allow or deny. Then call $ACL.accessRule.rule, or SetAccessRule if you mean to replace matching rules. Finally, set ACL.literalPath$ACLObject$ACL. For the share layer, use getSMBShare and getSMBShareAccessName ShareName. For reporting, expand the access property from getACL and select Path, IdentityReference, FileSystemRights, AccessControlType, and IsInherited. Here is a real audit-style scenario. Security asks, who can write under the finance share and where did inheritance get broken? First, get the share. Get SMB share, name finance, then read its path. Next, get SMB share access, name finance, and confirm the share grants are boring. Usually a controlled group with change, maybe administrators with full. Then walk the file tree under the share root and run getACL for each item. Filter access where IsInherited is false. That report is your map of exceptions. Hunt for everyone, authenticated users with write, modify, or full control, and identities that display as raw SIDs starting with S1521. Breaking inheritance is not just a checkbox, it is a design decision, and it needs a ticket, an owner, and a reason. If you use $ACL.setAccessRuleProtection$true, you are protecting the ACL while preserving inherited entries as explicit entries. With $true, $false, you can remove inherited entries. That is sharp. Deny entries are legal, but they confuse troubleshooting and should be rare. PowerShell 7 is fine on Windows for getACL and setACL. This is still Windows security descriptor territory, not Linux permissions. Windows PowerShell 5.1 behaves similarly here, but old scripts may depend on formatting or .NET constructor quirks. NTFS permissions sit right in the middle of Windows administration. Active Directory groups should be your permission units. Users should not be sprinkled directly on folders. Group policy or GPO can set some security baselines, but daily file server access is usually group membership plus share and NTFS design. Event logs tell you what failed or changed if auditing is enabled. Your automation job is not to make permission changes faster at any cost. It is to make them consistent, reviewable, and reversible. Good ACL scripting connects identity, file servers, audit policy, and change control. Try this safely today. Pick a test share or a lab virtual machine. Do not run Set-Acl against production for practice. First run get-SMB-share-name test share and note the path. Then run get-SMB-share-access-name test share. Now run the snippet from the description with the root path changed to your test share path. Open the CSV and look only at non-inherited entries. Ask 3 questions: who is named, what right do they have, and why is inheritance broken here? If nobody can answer the why, that permission is technical debt. 3 beats to keep. First, effective access is the most restrictive result of the share layer and the NTFS layer. Check both before you blame the user, the network, or the application. Second, the safe PowerShell pattern is Get-Acl, modify the existing object, then Set-Acl. Do not invent a fresh production ACL because it looked cleaner in a script. Third, report every non-inherited access control entry under the share root, then HUD broad grants and orphaned SIDs. Tomorrow we keep building the administration tier. New PowerShell episode daily on this channel.